Hi, good morning class. This tutorial that we are going to do this morning is for the standards 2 and 3 students. Now some of the work that will be covered today would be work that you have already done, and you might think that it is easy. No problem, but I have to cover everything. Some of it you may have not done as yet, and like if you are a standard 2 student and you may not have done as yet, all you have to do is pay attention. And now is a time, the more that you are able to learn, it would be better for you than not learning anything at all. Okay, so I decided to do fractions in terms of what the standard 2 and 3 would have to do, pertaining to the curriculum, okay, as much as possible. Now there may be things that are left out or things that are added on, so we just try to benefit from it so that you would be able to do your test papers as well, your papers that were given to you, that you took home last Saturday, or papers that you would get in the future. Okay, so this tutorial is a video that you can keep, and you can keep looking back at it. Right, so we have here some definitions for fraction. Okay, now what is a fraction? A fraction is a part of a whole. Okay, now if we say a fraction is a part of a whole, the first thing that you will think, well, what exactly do we mean by a part of a whole? The word whole here can be actually confusing for some students. A whole is actually simply one of anything, one. Okay, so it could be one pizza, it could be one classroom, right? Class of students, it could be one country, one case of soft drink, it could be a bag of marbles, it could be almost anything. Okay, but one is basically a group of items together. All right, now once you start selecting things from that group, right, not necessarily separating it, but separating it in terms of selecting parts of it, then as the word implies, it can be broken into parts. It can be broken into parts. So therefore, a fraction is a relationship between parts and whole, right? Parts and a whole. Therefore, if a classroom has 24 students, 5 of those students will be a fraction. Okay, so 5 of those students from your class. Now I don't know how much students your class has, but any amount that you select from the classroom, and you select or you indicate from the classroom, then that would create a fraction. So say supposedly if we had a class, which is 1. Okay, 1 class. However, we have the 1 is equal to 24. So we have 24 students. Okay, right? So the classroom is 1. 1 is equal to 24. Now from that, we can have 11 boys, right? And we can have 13 girls. This is what I mean we select a part of. So 11 is a part of the class, and 13 is also a part of the class. All right, so this is just indications of how you still have a whole of something, but you indicate a part of it. Okay, a lot of teachers actually use one of the first things that they use as well in terms of fractions is drawings. A lot of teachers use the pizza, and it even comes, you start using the pizza from standard 2, and it can actually come, they use the pizza even for the SEA exam. So it's pizza all the way, right? So if it is that we say this is 1 as well, okay, but we ate 3 slices of the pizza, it is still 1, right? So the pizza is still 1. The pizza is still 1, okay? However, the part that is eaten is 3, okay, and the part that remain will be 5, okay. Now this 3 and 5 would still make up the 1, which is really the same as what we said before. 1 is actually the whole. Now you have to remember 1 is the whole, but a whole of anything can be separated into parts, okay, creating fractions, okay, based on what exactly we are doing. If we have a case of soft drink or a case of water, many of you have bottled waters at home, okay. So if it is that we have a case of water, if you'll go and you look at it right now, okay, a case of water, 1 case of water is equal to a whole, okay, which although it is 1, it is a whole, it is also equal to 24 parts. It is also equal to 24 parts. I'm saying that again. So we have 1 is a whole, which is equal to 24 parts. Right? So you can take 1, which is a whole, you can take 1, which is a whole, which is also equal to 24 parts. Alright? Now say supposedly, now you have that case of water in your kitchen, or wherever you keep it, okay? Right? So we have this case of water. And right now, if you go and you look at it, we're going to separate it into parts. Now it is still a whole, the 24 parts, but we indicating now different things that it represents. So if you drank five bottles, that would be a fraction of the case of water, and whatever remain which is 19 bottles, that will also be a fraction. Okay, so again we're looking at something right in our household, a case of water, 1 is equal to 1 is equal to a whole, which is 24 parts. Okay, you drank 5 bottles, which is a fraction of the whole, and what remained was 19 bottles, which is also another fraction. Okay, so we indicate different things that would represent fractions. So a part of a whole is we're going straight back up to the definition. Of what is a fraction. A fraction is a part of a whole. So a whole could be a case of water, a whole could be a pizza, right, divided into different parts, whether it be 8 parts or 12 parts, right? A whole could be a class of students, so 24 students. A whole could be anything that you buy in the grocery or whatever. Or a whole could be one block of something, like one block of soap or anything, and you decide to separate it into different parts. Or you choose it, probably like the pizza. When the pizza was baked, it was just one whole, and then we divided it into different parts, creating fractions. Okay, right? So we're going to look at the next aspect of fractions as it normally comes, right? So this aspect of fractions basically is identifying fractions from drawings. Okay, so basically what happens, the first thing that they do is to actually color in or highlight a certain amount. But we first have to establish, what I would tell students to do all the time is to firstly to establish what we call the denominator. The denominator would be the number. Now we separate the part from the whole using a line. Okay, I should say that first. I'm saying that again, we separate the part from the whole using a line. Okay, right? So the whole would be all. So let us count how many smiley faces we have here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So our, what you would call our denominator would be 13. Okay, so if we were to now separate that into parts, and we decide to highlight a certain part, okay, the amount highlighted would be a fraction. Okay, so we would have here, and we're going to count again, 1, 2, 3. The amount highlighted disappeared, so let's see if we could get that back. Let me see if I could get that back for you, even if it's not the exact amount. So you will have to count it. You'll just have to pay attention and count it. So we have 1, 2, 3, 4, 5, 6. Okay, so therefore, if we were to say how much was shaded, we would say 6 was shaded. All right, 6 was shaded. Right, so we have here 6 was shaded. So if they ask us what was the fraction that was shaded or how many was shaded, expressed as a fraction of the whole, okay, we would be able to say that 6 was shaded as a fraction of 13. So 6 is our what we call our numerator, and 13 would be our denominator. Now 13 is the whole and 6 is the part. Okay, so six is our part and 13 is the whole. All right, so 6 is the part and 13 is the whole. So first we establish, we're going back again to number 2 to use as another example. Now here we have a set of birds. Now we have to try to figure out how much. Again, we have our line to separate our part from our whole. We're going to put the whole at the bottom, creating a denominator. So we have to try to figure out here how much is the whole. So you can take your time and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, so let us check that again to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we know that that is the total. So the total or the whole would be our denominator. And if we were asked to indicate how much was shaded, then of course we would have to count how much was shaded. 1, 2, 3, 4, 5, 6, 7. So 7 was shaded. Therefore, our numerator would be 7. So 7 is the part and 20 is the whole. Okay, so the whole is the denominator and the part is the numerator. Okay. So the 20 is the denominator. And the 7 is the numerator. All right, so we will be doing over that because it isn't as neat as we would like it to be. All right, we would be doing over that to make sure that you understand it better in terms of the word and the spelling and stuff like that, but we don't have enough space to write it properly. So let us look at number 3 as another example. So we keep doing examples so that you all, if you didn't get it in number 1 or number 2, hopefully number 3 you would be able to get it. Okay, so we have here sunshine. So we want to try to establish how many do we have for our denominator. So that's the first thing we always do. Try to establish our denominator. So one way to do it is 1, 2, 3, 4, 5, 6, 7, 8. We have 8 on top, and then we have to the side. We have 8 going across, sorry. Let me count it again. 1, 2, 3, 4, 5, 6, 7, 8 going across, and then 1, 2, 3, 4 going down. 8 fours are 32. So we have a big number there. Okay. And if we were to highlight 2 rows, okay, and they ask us how much was shaded, what would we say? So let us count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Or we can easily say 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. 8 twos are 16. Okay, so there are various ways. If you get a big one, like one with a lot, you can easily just use different strategies to get your answer quickly for the older students, the standard 3 students. So you don't necessarily have to count it like that. You can actually use your grouping, your timetables to get your answer faster. So with the ladybugs here, let us try to establish what would be our denominator. So again, we have 1, 2, 3, 4, and then we have going down again 1, 2, 3, 4, and then we have going across 1, 2, 3, 4, 5, 6, 7. So 7 fours are 28. Right? And if it is that we had to say shade off, how much was shaded? We're going to check. For the smaller kids, you can actually check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21. So 21. 21 over 28. All right, now those are pretty big fractions, okay, but it doesn't matter how big it is. Once you have the correct denominator and numerator, it is correct. Okay, all right. So if we look at number 4 here and we try to establish our denominator, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9 for our denominator, and our numerator, if they ask us how much is shaded, it would be 3. Easy. Okay, so I hope as we go along it is getting easier for you all, especially the standard 2 students. All right, so we have number 5. How much do we have here in total? We have 1, 2, 3, 4, 5, 6 going across, and then 3 going down. So 6 3s are 18. And if they ask us how much was shaded, we would have 1, 2, 3, 4, 5. 1, 2, 3, 4 going across and 3 coming down, leaving us with 12 that, was shaded. And for this last one that we have here, which is quite easy, we're trying to make an easy, familiar one for you as well. We have a denominator of 4 and we have a numerator of 1. So again, for this easy one that we have here, that is one of the first one that you would actually learn in standard 2. We have the quarters and the thirds, etc. All right, these would actually be some of the easier ones. Okay, so we have a total of 4 for our denominator, and 1 part was shaded, which is our numerator. I want to go a little further down because we talk about most of what we spoke about is what is shaded. All right, so we want to take a look at shaded and not shaded. Okay, so we want to take a look at both aspects because a question could ask you to identify parts that are shaded and parts that are not shaded. Okay, so for this part here, if the question asks to identify what was shaded in terms of a fraction, okay, so first we have to establish the denominator, which will be 12, and the numerator, which will be 4. And if they ask us for not shaded, again our denominator will be the same. Our numerator, however, would be the remainder, or what will be obvious to you that is not shaded, okay, which will be 8. So we have two fractions here. Okay, we have the shaded part. Okay, now again we're going back to our original concept, right? This whole diagram here is 1, which is a whole, which is also 12 parts. Okay, so the 12 parts or the whole is always the denominator, right? And the other parts that are either shaded or not shaded will be our numerator. Okay, so 4 parts are shaded, so that will be our numerator. 8 parts are not shaded, so that will be our numerator for that question. Okay, so it is pretty easy. Now that was a long discussion for something that some of you probably already know, but you have to be a little patient. Okay, so we have a question here where we have to actually shade. We have to shade 7 out of 15. So already established the fractions, and now we have to shade 7 parts. 1, 2, 3, 4, 5, 6, 7, and that will be our answer. Okay, and here we have they asked to shade in the fraction 8 out of 24. 1, 2, 3, 4, 5, 6, 7, 8, and that will be our answer, right? So some of you have to actually color in or whatever your answer that was given to you on worksheets. So you actually have to just color it in 1/4. So we color one part. And the last one here we have 1/3. Okay, so some of these are pretty basic, very easy for you to do. All right, so one part that I didn't really add in, I'm going to do it so my whole page is actually right. Finally, we're going to look at I didn't actually prepare a whiteboard for that, but I know that this is something that we also have to know how this is like the numerals. So we have a half, we have 1/3, which will be 1/3. So we're going over the word name for some of the fractions. Now if we have 2/3, if we have 2 as the numerator, we just write 2/3 and so on. Okay, then we have the quarts, like 1 quarter. So 2/4, for example, would be 2 quarter. And we go on to another one. We have, if it is divided into 5 parts, we say one fifth. If it is 2/5, we say 2/5, 3/5, and so on. Okay, one sixth, one seventh, one ninth. Right, and we could just keep going on and on with that. So you just have to know how to spell the word and put TH at the end, THS, okay, for some of them. So let's go back to the top to some of the wording. Okay, so we have 1/2, 1/3, we have the thirds, right? Then when we go on to denominators of 4, we have the quarters. Then with a denominator of 5, we have the fifths, denominator of 6, we have the 6, denominator of 7, we have the 7s, denominator of 8, we have the 8s, denominator of 9, we have the 9s, denominator of 10, we have the 10s, and so we keep going on. All right, so you have to know your word name as well. Now we have here types of fractions. Now types of fractions. The first type of fraction that we have would be a proper fraction. A proper fraction is where the numerator is smaller than the denominator. So 2/3 would be a proper fraction. Okay. Other examples can be 15/26, 1/2, 3/7. All of those are proper fractions. Again, the numerator is smaller than the denominator. Then we have improper. So while I'm writing, this is something for you to think about the word. If this was proper, then what would be an improper fraction? An improper fraction is where the numerator is larger than the denominator. Okay, so we have other examples. Oh dear, it went straight off the lesson. 26/8. Okay, we have 8/3. Now if you look at it, the numerator is larger than the denominator. The numerator 26/8 is larger than the numerator is larger than the denominator. 26 is larger than 8, 8 is larger than 3, 12 is larger than 5. Okay, and then we have so far, let me just go back before we continue. We have proper fractions, we have improper fractions, and what do you think will come next? We have the mixed numbers. The mixed numbers will be a combination of whole numbers. So we try to write the whole numbers a little bigger to start when we now learning. Okay, so it will be a combination of whole numbers and a fraction. Okay, so other examples of that: So mixed numbers sometimes are very simple, like 1 1/4. Okay, and it could be very huge. Well, at least huge for some of you who are in standard 2. Okay, but it doesn't matter how huge it is. As long as we have that combination of a whole number and a fraction. So a mixed number is a combination of a whole number and a fraction. So we have 3 being the whole number and 2/5 is the fraction. We have 4 being the whole number and 1/4 is the fraction. We have 13 being the whole number and 3/10 is the fraction. We have 1 being the whole number and 1/4 being the fraction. We have 26 being the whole number and 15/20 being the fraction. So again, let us go through that quickly. We have proper fractions, which is like 2/3, where the numerator is smaller than the denominator. We have improper fractions, where the numerator is larger than the denominator. Then we have mixed numbers, which is a combination of a whole number and a fraction. Okay, so let us look at the next aspect of learning for today, which is changing an improper fraction to a mixed number. So can we remember what is an improper fraction? An improper fraction could be like 13/5. Okay, so first we divide, right? We have to know our timetables to do fractions at this time. So this is for the standard 3s. I want to remind the standard 3 students that do not take this time while you are at home to learn your timetables from what Miss say we reach until 6 time, we reach until 7 or 8 and feel okay. That is all well and good, because when you go to standard 4 you would not be learning timetables anymore. It would be assumed that you know your timetables. Okay, because standard 3 is where there's a cutoff period for learning timetables. You might get, if you don't know your timetables, you might get a complaint from your teacher to your parent that you're getting your work wrong because you don't know your timetables. But they would not spend time in the standard 4 class teaching you timetables. So while you're at home, you should learn your timetables from 1 straight to 12. Okay, because if you don't know your timetables, you can't multiply and divide. And in standard 3 we have a lot of multiplying and dividing, and when you now go to standard 4 as well, that is one of the first things to start practicing multiplication, adding, subtracting quickly, and then they move on to multiplication and division quickly, and because they want to get to all the other topics. Okay, so we must know how to divide. Here we have here 13/5, and we're going back to the topic, changing from an improper fraction to a mixed number. So this obviously is an improper fraction. Okay, that is an improper fraction, 13/5, and we're going to change that to a mixed number. So we ask ourselves, how much times can 5 go into 13? So we have to know our timetable. So we say 1 5 is 5, 2 5s are 10, 3 5s are 15. Now 15 is too high, so therefore 5 could go into 13 2 times. Okay, so that will be a whole number, because remember we are changing it into a mixed number. A mixed number is made up of a whole number and a fraction. So 5 into 13 is 2. and then we have a remainder of 3, which we put over our denominator of 5. So we keep the same denominator, 5. This is really the remainder. Okay, so my handwriting on the whiteboard isn't the neatest. I hope that you all are still able to understand. Okay, again, we're going to go to our next example. So we're going to look at a simpler one. So we have 4 over 3. How many times can 3 go into 4? 1 time. And what would be our remainder? 1 over, we put that over 3, creating a mixed number. We're going to look at another simple one again. So we're trying to look at simple 5 over 2. How many times can 2 go into 5? 2 can go into 5 2 times with a remainder of 1. And then we put it over the denominator. We keep the same denominator. Let us look at another simple one. We have 7 over 3. Okay, how many times can 3 go into 7? So we're thinking our 3 timetable. 1 3 is 3, 2 3s are 6. So it will be 2. And we have a remainder of 1 that we put over our same denominator. Okay, so even if we look at a bigger number, we have some big numbers as well. Okay, so if we have 58 over 7, how many times can 7 go into 58? That will be 8 times, because we know our timetable, right? Because 7 8s are 56. So therefore 56 from 58 will give us a remainder of 2. So we have 8 and 2 over 7. We're going to look at another big one. Okay, because we have to be confident and standardary with our timetable. Okay, so if we have 99 over 10, how many times can 10 go into 99? 10 can go in, because we know our 10 timetables. We know it can go into 99 9 times. And what will be our remainder? 9. So we put it over the 10. I hope by now that you get the idea, the general idea. First you have to divide, then you find the remainder and you put it over the same, right? It's over the same denominator. So first you divide and you put the remainder over the same denominator. So we go into our next topic. I think this might be our final one. I'm not too sure. Let me check for you. Sometimes it's a little bit difficult to... Oh no, we have another one after this. We have 2 after this actually. Alright, which is not a problem. Right, so today would have been your day to do maths, to spend in class with Miss, and we're going over fractions. So you could listen to it and then you play it over again. Make sure that you understand the topic clearly. So we're changing from a mixed number to an improper fraction. So we're going to do the opposite now. All right, so we have we're changing from a mixed number, so we have 1.5. We're taking a simple one. So first we multiply and then we add. So 1 2 is 2, add 1 is 3. So our answer will be 3 over 2. If we have another one, 2 by 5 is 10 and 3 is 13. So our answer will be 13 over 5. Now let us go back to the first question. We have 1 times 2, add 1 will give us 3, right? And we keep the same denominator. Alright, now creating an improper fraction. So therefore the numerator is bigger than the denominator. 2 by 5 is 10, add 3 is 13, and we keep the same denominator. So therefore the numerator is larger than the denominator, creating a improper fraction. So basically that is what we have to understand what we're doing. All right, let us look at another example. We have 5 and 2 over 7. So 5 by 7 is 35, add 2 is 37 over 7. Now we keep working at more difficult examples. We have 10 and 3 over 8. So 10 by 8 is 80, plus 3 is 83 over 8. So again, the numerator is larger than the denominator. When working, we have to remember to multiply first and then we add the numerator. So 11 by 8 is 88, plus 6 is 94 over 8. So we can't be afraid of the big numbers. It is the same thing, the same working, and we are supposed to know our timetable. So we multiply by our denominator and we add our numerator. Okay, so 1.5, change that improper fraction will be 3 over 2. Because an improper fraction, the numerator is supposed to be bigger than the denominator. So if we look at all of them, the numerator is now larger than the denominator. Okay, so we're moving on to adding two fractions with the same denominator. So if we have 1 over 2 plus, alright, so let me don't use that example because that would lead to confusion with you all. If we have 1 over 3, add 1 over 3. So what we have to do here is that we have to add the numerator and keep the same denominator. So in this case, we keep the same denominator and we add the numerator, which is 1 plus 1 is 2. If we look at another one, 3 over 8 plus 2 over 8. So again, we keep the denominator and we add the numerator. 3 plus 2 is 5. Easy? It is actually quite easy. But I will show you a few more examples just to make sure. Okay? So we have 1 over 5 plus 3 over 5. Notice all the denominators are basically, for the additions, are the same. So we keep the same denominator and we just add the numerator. 3 plus 1 is 4. We can even have bigger numbers. We always like to use the bigger numbers too. I like to always use the bigger numbers too, so we gravitate from smaller to bigger so that you all will be able to understand that the same thing applies no matter how big the numbers are. So if we have 3 over 24, add 15 over 24. 15 add 3 is 18, and we keep the same denominator. Now we wouldn't do simplifying or anything like that, so if parents are looking on, you know that some of these numbers you can probably simplify it, but that will be too much for them right now. Okay, we're just trying to learn the basics, and they would learn simplifying later on. Alright, so even if you have 25 over 50 plus 8 over 50. Right, 25 and 8 is 33 over 50. So we are trying to establish here that even if we start with a small recognizable fraction and we move down to bigger numbers, it is basically the same. We add the numerator and we keep the same denominator. Okay, I believe that we have one more, which is subtracting fractions. So if we have 3 over 5 minus 1 over 5, we keep the same denominator, we minus the numerators, and our answer will be 2 over 5. Alright, if we have 4 over 6 minus 2 over 6, we keep the same denominator and we minus our numerators. It will be 2 over 6. Look at a slightly bigger number, 10 over 15 minus 5 over 15. Our answer will be 5 over 15. If we have 16 over 25 minus 8 over 25, our answer will be 8 over 25. So in doing your work, you have to be confident in your answers as it moves on from the smaller numbers to the bigger numbers. And again, if we go back to the addition, we would see a similarity to the subtraction, where we have the same denominators, same denominator. So all we have to do is to add the numerator. 3 plus 15 is 18. Okay, same denominator, same denominator. We just add the numerator. 25 and 8 is 33. Okay, if we go on to subtracting, if we go on to subtracting, we see that we have same denominator, same denominator. We minus the second digit from the first digit like any other subtraction, and we get our numerator. Okay, so we keep the same denominator. Our numerator is where we do the subtraction and the adding. Now that can only occur if we have the same denominators. Same denominators. Same denominators. When you go on to standard 4, some schools start you up at standard 3 as well, where you have to find LCM and stuff for when you have different denominators. But for now, don't worry about that. Okay, we will do that as we move along. Okay, so again, I'm highlighting here same denominators. Same denominators. Okay, all of them would have had the same denominator. So all we had to really do work on was basically our numerator. Alright, so I hope that all these topics that we did on fractions would have helped you in some way to do your test paper. That was given to you. Wasn't really a test paper, but really exercises that were given to you. Now at the end of it, basically we want to try and do over the topic in terms of a little, not a test so to speak, but a combination paper where you will have every aspect of it. Okay, so I try to cover everything as best as possible. Now sometimes the whiteboard, we have problems with navigation and the whiteboard, etc. And we are still trying to reach out to you in order for you to learn the topics. Like right now, this board here is stuck. I don't know for what reason. It isn't moving. Oh, look, it's moving now. Slightly. Okay, so I hope it is that you can look at it. This video is pretty long, but if you were in school, at least you would have to stay in class probably for an hour or something without break. But with this video, you can actually pause it, you could rewind it, you could go and get something to eat, something to drink. You can actually do, as you do each paper, you could listen to each section of the video, because each section should cover each paper that you have gotten, whether it be to shade a fraction or to say what part is shaded, or if it, whatever it is in fraction, if it is to name the fraction, like the word name, etc. So each part of the video covers everything. So I hope that it was useful to you, even though we had little problems in between, but basically the information is correct and you can keep it and look over it, right? So that's the benefit of online classes in this aspect and not live classes, because if you have live classes, when the session is over, that is it. Okay, unless for some reason or the other you are able to screen record or whatever. But in this case, you just have a video that you could look through in WhatsApp or on your tablet or however else you can share it from one device to the next. Alright, so I'm looking forward to you all bringing in back your exercises and getting, if not most of it correct, all correct. And have a good day.